For this piece of the lecture, we're going to look at conversions between systems. There's no trick to this, it's just dimensional analysis. So it's more problems based on what we were doing last week. I'm going to go through several of the more challenging ones. I'll let the easier ones for you because you know how to set up a dimensional analysis problem, and you can just use the conversions directly out of your pre-lecture notes. Do keep in mind that those that are in your pre-lecture notes need to be memorized, so make some flashcards and work at this week. So for our first example, we're going to deal with an apothecary measurement, and the apothecary system typically uses fractions instead of decimals, so using a fraction within dimensional analysis can be a challenge. The thing that guides dimensional analysis is labels, so our label here is green. And so even though there's a fraction bar, this 1/200th all goes on the top of the fraction of our dimensional analysis, so all over 1 because there's only one label. The label is green. Now you'll notice I switched to writing green behind my number, and that's just more comfortable for me when I'm doing a problem. So I want to multiply by my conversion factor, and I've memorized that 1 grain is 60 milligrams. So I set this up so that the label of grains cancels, and I'm ready to do my math, and I see that the label that remains is going to be milligrams. So what I need is a calculator. So let me pull my calculator in here. And on our calculator, we have 1/200th. So 1 divided by 200. That whole piece is just typing that first number. Then we're going to take that times the 60 that we set up and equals, and there we have our answer of 0.3 milligrams. And so this is a decimal amount, which is what we want because we're in the metric system at this point. So key thing to remember with dimensional analysis, if you have a fractional number at the beginning, it all goes in the top of the fraction if it only has one label. It's the two different labels that make the two parts of the fraction when we were dealing with rates like miles per hour last week. So let's look at another one. This one asks us to go from meters to inches. Now if we look in our pre-lecture notes, we have a conversion from centimeters to inches. So we have in our notes that 1 inch equals 2.54 centimeters. But I'm at meters, so I'm going to use my metric line. So King Henry died by drinking chocolate milk full of microorganisms. So I am currently at meters, which is a base unit, and I want to go to centimeters because that's what my conversion is. So I'll need to move my decimal 2 places. So I now have 120 centimeters. Then I can set up my dimensional analysis, so over 1. And I know that I want centimeters on the bottom, so 2.54. And 1 inch on the top. So centimeters cancels. I'm ready to have my calculator. So I had 120. Oops, let's clear that. 120. And in this case, the 2.54 is in the denominator, so divided by 2.54 equals, and we get this whole long answer, so 47.244. Now I look at the directions for my problem and it says round to tenths, so here's my tenths place, and so I give my answer of 47.2 inches. So this two-step process, first we did a metric conversion using our metric line, and then we did a dimensional analysis problem using the conversion off of our pre-lecture notes. Our next one is a two-step example as well. Many times infants here in America are measured in pounds and ounces. However, as we to medicate them, most of the meds are based on kilograms. So we have 2 parts in our label, we're going to have 2 parts in our problem. The first part to this problem is to convert the ounces into pounds. So I'm going to take my 13 ounces, put it over 1, and I have 16 ounces is the same as 1 pound. So I'm going to have to do on my calculator 13 divided by 16. So clear 13 divided by 16. I don't want to round here. So 0.8125. So this equals 0.8125, and the label is now pounds. My next step is to take this 8 pounds and combine it with this ounces in pounds. So my child weighs a total of 8.8125 pounds, adding those two numbers together. And then I want to convert that to kilograms. So from my pre-lecture notes, which I'm going to memorize, 2.2 pounds is the same as 1 kilogram. So again, I'm going to take my calculator and do this. I see that up here it tells me I'm to round my final amount to tenths. So let me get my calculator. Let's move this over so I can see everything that I'm doing here. There we go. So I already had my decimal, so I'm going to add the 8 pounds. So there's the total weight for the child. Then I need to divide that by 2.2. And I'm going to round it to tenths, so 4.0. Now the thing I have to remember is that in the metric system I'm not allowed to have a trailing 0. So when I go to write my answer, I'm just going to write 4. If it makes you feel better, I can write it down here, 4.00, so that I can see that I rounded that correctly to just 4. When we're dealing with pounds and ounces, it is always a two-step process, so always a little bit longer of a problem. Again, when we deal with heights in America, we deal with feet and inches. So when I tell you how tall I am, I would say that I am 5 foot 2 3/4 inches. And so I wouldn't just say that I am 5 point and give a decimal feet, and I wouldn't give my height completely in inches. So again, with two labels, a two-step conversion. So we're going to start with what we're given, 97 centimeters. Put it over 1. And we learned on our pre-lecture 2.54 centimeters is the same as 1 inch. So that's my first conversion. And so I'll get my calculator, clear, and then 97 centimeters divided by 2.54. So I have 38, and at this point in this problem I can round to a whole inch. I have 38 inches. So going back to my problem, equals 38 inches. Now you can probably do this in your head. We know that there are 12 inches to a foot. I'm going to write out the math just so that we see it if we have one we can't do in our head. So inches, and I know that 12 inches is 1 foot. So if I do the math on this, I would have 38 divided by 12 3.16, and the 6 repeats. Now most of you probably in your heads had already figured out that 38 inches is just a little bit over 3 feet. So I don't want to give my answer with this decimal though. I know I want to give my answer with 3 feet, but I want this decimal to actually be a number of inches. So to convert that back, I can subtract out the whole number. So that way I just have the decimal. And I want that to go back to inches, so I want to undo the conversion that I did here. So I want to take this and multiply it by 12. And I'm right back to 2, which many of you would have done in your head. So this is 3 feet, that'd be 36 inches, and 2 remaining inches. So that way I give my answer in both feet and inches. And down here, we had this 3.16 and the 6 repeated. The way to change this decimal is to take just the decimal, notice I didn't include the whole number, and multiply that back by 12, and that gives us the 2 inches. And so that's just undoing the conversion that I did here to switch it back to inches. So these problems that we've looked at are some of the hardest examples rather than the easy examples. I think you can do the easy ones on your own because we looked at dimensional analysis already last week. Key in this is that you memorize so that you know the conversions, measurements, and abbreviations in your notes. And that's your pre-lecture packet. There are so many other conversions in your book and in your workbook, and you're never going to have to memorize them. Just the ones in your pre-lecture notes.